Hey third graders, today we're going to create a factor tree and we're going to need to use our knowledge of prime numbers. Remember, a prime number is a number that can only be divided by 1 and itself. Okay, so I'm going to show you how to do a factor tree, a few of them. I think you'll catch on, and then I have a few numbers that I want you to factor tree using it as a verb. I'll show you what I mean in this video. So pay attention. Don't get too confused. I'm going to go nice and slow and show you the way to go. Okay, the first number we're going to turn into a factor tree example is 24. 24 is not a prime number. You don't need to worry about that right now. We're going underneath 24, follow this first step. Put 2 marks under 24 like you're splitting it, okay? Okay, the reason this is called a factor tree is because the word factor means the multiples. So under 24, what's a way I can make 24 multiplying? In other words, what times what times what gives me 24? Well, there's a few right answers. 2 times 12, 4 times 6, 3 times 8. I'm going to go with 4 times 6 because that equals 24. Okay. First step, write under the number, whatever number I give you, how you multiply to get that number. There's no wrong answer as long as it equals the number. So 4 times 6 worked, 3 times 8 could have worked, 2 times 12 could have worked because they all equal 24 when I multiply. Okay, just let that sink in. 4 times 6. Why does that work? Because it equals 24. The next question, are these prime numbers? Are either of these prime numbers? That means, is there any way I can multiply 4 evenly besides using 4 or 1? Yes, there is. How about 6? Is there a way I can multiply to get 6 besides 6 times 1 or 1 times 6? Again, the answer is yes, there is. So if the number isn't prime, then you go like this again. You're splitting again. So from way back, it sort of looks like a pine tree. That's where the idea of factor tree comes in. Okay, so I'm splitting it again. How do I make 4? Well, 2 times 2. And how do I make 6? Well, 2 times 3. Okay, notice my last row. They're all prime numbers. 2, 2, 2, and 3 are all prime numbers. When my last row is full of prime numbers, I'm done, and that's the bottom branch of my factor tree. Notice here, 4 times 6, those weren't prime numbers, so I had to keep splitting until all I had left was prime numbers, like 2. So 24 is 2 times 2, times 2 times 3. So what did I do? This multiplied equals that, and they're all prime numbers. Let me give you a hint, children. Your bottom row is going to be full of 2s and 3s. Okay? So that's a big fat hint. Notice my first example, full of 2s and 3s. Let's try another number for the factor tree. Example number 2. Okay, 32. First thing I got to do is split it because I need to make a factor tree. Okie doke. Last practice. 50, huh? How am I going to split 50? Well, there's a couple ways to make 50. It doesn't matter where you start because your ending is going to be the same. I'm going to make 50 by taking 5 times 10. I could do 10 times 5. I could do 25 times 2. I'm going to do 5 times 10. Now, I have a 5 and a 10. One of these numbers is already a prime number, meaning I can only divide it by 1 and itself. Which one is the prime number? 3, 2, 1. 5 is already a prime number. So I'm not going to split 5. I'm just going to bring it down. There I bring in my row down again. Here comes my times sign. Now 10. 10 is not a prime number, so I got to split it. When I split it, I need to make 10 with a multiplication sentence. What times what gives me 10? Well, 2 times 5. Okay, notice 2 is a prime number, and so is 5. So now I bring down my 2, I bring my x down, my multiply, and I bring this 5 down, and that's my last row. First question, does that row equal 50? Well, what's 5 times 2? 5 times 2 is 10. Okay, what's 10 times 5? Well, that's 50. That's what I wanted. Are all my numbers in the bottom row prime numbers? Well, yes, they are. 5 and 2 and 5 are all prime numbers. That's how I know I did it right. And it equals 50. So you're splitting until you get a prime number. And remember, prime numbers like 2, 3, 5, 7, you're going to see those in the bottom. You can't split those. Those are prime. Okay? Good luck. Try to show me your work. I want to see your tree. Just like I showed you my steps, I want to see the work. That's why I'm only giving you 5 problems to do for the whole thing, because I want to see your tree. Looking forward to seeing your math. Good job, everybody, and thanks.